Welcome to section 4.7. This is a continuation of 4.7, and we're going to be talking about the discriminant. And as you can tell by this key concept diagram here, the discriminant is the part of the quadratic equation that's underneath the radical. This part right here helps us determine what type of solutions will be found from the quadratic formula. Either they will be real or imaginary. So if the discriminant is a positive number, it's going to be real. If it's a negative number, it's going to be imaginary. Here's what an imaginary looks like. Imagine the variable I is the same thing as the square root of -1. As you know, nothing times itself will equal a negative. So there's no way you can actually solve for this, but it does represent a solution in algebra. Since there's no real solution, there has to be an imaginary solution, and that's when we use the letter I. An example of an imaginary number would be the square root of -5. Another one would be the square root of -11. Another way you can look at imaginary numbers is 2i. That says 2 times the imaginary number of the square root of -1. We can also have something that might need to be simplified, such as -20. We know that 20 has factors of 4 and 5, so we could actually simplify that imaginary number, kicking the 4 out as a 2, and still having the -5 underneath. But this is not simplified all the way, because we can now kick that negative out as an I. Same thing here. This is I radical 5. Same thing here. This is I radical 11. Let's take a look at this in action. We need to find the type of solutions from the following quadratic equations. Here's our first one. Now remember, our discriminant is what's underneath the radical for the quadratic formula. Quadratic formula is -b plus or minus the square root of -b squared, or excuse me, I got too many negatives here. How about just b squared minus 4ac? That's all underneath the radical, divided by 2a. But since the discriminant is just the stuff underneath the radical, I'm going to pull that out and use that as our formula for the discriminant. So let's take a look at our first equation. We've got a is 2, b is -1, c is 5, and we're going to plug those in. Please watch your negatives and make sure they're in the right location. Plug in our a and c value. A is 2, c is 5, and we're going to have 1 minus 4 times 5 is 20 times 2 is 40, and that's going to equal -39. Now, since this is negative right here, that means you're going to have imaginary solutions. And since our degree is 2, we're going to have 2 imaginary solutions. Let's take a look at the next one. Here, we've got a quadratic equation that is not set up in standard form, but we can quickly change that by subtracting 4x from both sides. Set it equal to 0. Then use our discriminant. And just plug in the values. -4 squared minus 4 times a times c, and simplify. That's going to be 16 minus Well, that's going to be 16 times 3, which is going to be 16 times 3, 48. And that's going to leave us with negative 32. And again, that's going to mean we have imaginary solutions. Just having a problem here with my pointer here. There we go. Let's just put a little dot here for imaginary solutions. Let's take a look at one that's going to have real solutions. Say, for example, we had 2x squared minus 10x plus 4, and use the discriminant b squared minus 4ac. And that's going to be 100 minus 4 times 2 is 8, times 4 is 32. That's going to equal positive 68. So that means we're going to have 2 real solutions. When we graph these quadratic equations, you will see that when they have 2 real solutions, these graphs are going to cross the x-axis. Same thing here, they're going to cross here and here. That's why we're going to have the 2 real solutions. A special case of real solutions is when the graph bounces right off the x-axis. When it has that bounce off the x-axis, you're going to have just one real solution. The other example, or the counterexample to real, are the no real solutions, in other words, imaginary. Is where the graph does not cross the x-axis. This would be a great diagram to have in your Cornell notes, just as this part would be great for your Cornell notes, and of course along with your examples. The discriminant is helpful when you're trying to determine if a function is going to have real solutions or not. If you have real solutions, you can probably solve real-world problems. If you have imaginary solutions, you cannot solve the problem, but you will let the casual observer or the bystander understand that you have solved the equation correctly and that you have graphed it, yet it does not have any real solutions. It does not cross the x-axis. Remember from the last video that I said when you have quadratics, I'm just going to put the quadratic standard form up here. When you have the quadratic standard form, the degree right here is telling you the number of solutions. So if someone is casually looking at your equation, they're expecting 2 solutions. Well, if you have a certain type of quadratic equation, you might find 2 solutions, but they will be imaginary and it will not be useful to solving real-world problems. I look forward to seeing you guys in class.